Hydrogen is the most common element on the periodic table, and it makes up over 75% of the elements in the universe. It's also the primary ingredient in H2O, or water, the most common molecule in the universe. It's the lightest and most simple of the elements, consisting of just one proton and one electron, although sometimes it likes to pair up with a neutron or two and make some exotic compounds like heavy water. Hydrogen weighs roughly at 1 atomic unit and has an average boiling point of only negative 259 degrees Celsius or 14 Kelvin. While you typically find it paired up, it also comes in the form of ions, which are just a single proton fired from coronal mass ejections on the sun, or as a byproduct of acid, not that kind of acid, base reactions. It's also highly flammable and responsible for one of the deadliest airship disasters in all of history. While hydrogen has caused a lot of terrible disasters, its power is often used in rocket fuel, as it combusts very quickly and efficiently while weighing much less than oil. Due to its clean and efficient reaction with oxygen, it can also be utilized for energy capture, making it a much safer alternative to car batteries. Helium is the lightest and most common noble gas on the periodic table, which is a group on the far end that are the characteristically gaseous, light-emitting introverts of the elements. Helium consists of 2 electrons, filling up its first shell, making it unavailable for bonding, a feature of all noble gases. Helium comes in 2 different forms: Helium-3, which is a tritium decay product produced through nuclear fusion and a theoretical sci-fi fuel source due to its release of energy when combined with deuterium, and Helium-4, which is much more abundant and can be produced in a variety of ways, including a different kind of nuclear fusion or as a byproduct of alpha decay. Helium is colorless, odorless, and non-toxic. Its only interesting physical property is that it doesn't have any. However, it has many uses, including, well, but other than that, it's also used in MRI machines, which need ridiculously cold temperatures for their superconducting magnets, and helium comes in handy due to its icy cold boiling point at 4.25 Kelvin. Deep-sea divers also use it to breathe easier under pressure due to its low density and not being, extremely flammable like hydrogen, which means, yes, professional divers sound like this. Lithium is the 3rd element on the periodic table and consists of 3 electrons, leaving only 1 in the second shell, making it very reactive and able to form ionic bonds with its halogen buddies like fluorine. It's by far the lightest metal, weighing in at only 0.5 grams per cubic centimeter. For reference, the next lightest metal, beryllium, weighs over 3 times as much at 1.85 grams per cubic centimeter. Due to its weight, it's often used in rechargeable lithium-ion batteries because of their need to be lightweight and pocketable, including the one in your smartphone. However, environmental and health safety concerns due to its not so ethical mining process and, well, yeah, that's in your pocket right now. It's led to talks of replacing lithium batteries with less terrible ones, but other than the Method Man album, it's got tons of other uses too, like grease. Beryllium is the 4th element on the periodic table, aka the first one that starts with a B nobody can ever remember. It's a silvery lightweight metal with a high melting point of over 1200 degrees Celsius, and it's basically a stronger, lighter, much more expensive, and very toxic aluminum that also apparently tastes very sweet, so much so that it used to literally be called glucinium. It's used in aerospace and military applications due to its strength and lightweight, as well as being a key component in the James Webb Space Telescope because of its high melting point. It's also very useful for X-rays because of its transparency to the frequency, although in most applications it's much less commonly used than aluminum because it costs a whopping $6,000 per kilogram compared to like $3. In fact, it's so costly to extract that only 3 countries produce the metal: the US, China, and Kazakhstan, and it's mostly the US. But hey, beryllium is what gives emeralds their green tint. Boron is kinda boring. It's basically just Beryllium 2.0, but it's even more toxic, and it's even more expensive. It doesn't even really have any interesting uses. Like, beryllium is used by NASA and aerospace engineering and all this cool stuff, but boron is used to, treat yeast infections. And that's about it. Unlike most elements, almost all the boron in our universe was made in supernova explosions, due to its fusion product being very reactive. Yeah, boron is so unpopular that even its most common isotope would rather be something else. It's the main ingredient in borax, the household detergent you can use to make kid slime. So that's fun. You can also use it to make cubic boron nitride, which under the right conditions can actually be harder than diamond, which I didn't even know was possible. But it's so much rarer and pricier than diamond that I couldn't even find a single place to buy it online or even know what the industrial price is, so we likely won't be seeing boron rings anytime soon. Now, carbon is unique as it has exactly 4 valence electrons, which allows it to form all kinds of different shapes, which is how you can have something as strong as a diamond or as weak as pencil lead, both made out of carbon. It can form even weirder stuff too, like buckyballs or graphene sheets or carbon nanotubes. Really any shape you could think of, you can make out of carbon. I mentioned earlier that carbon has 4 valent electrons, which is perfect because that allows it to form up to 4 bonds. Atoms with only 3 valence electrons donate them to other atoms, allowing them to only form 3 bonds, and atoms with 5 or more valence electrons take in those excess electrons, and a full shell of electrons is 8. So once you pass 5, there's no more than 3 bonds that you can make. But carbon is at that perfect middle ground where it can form 4. Which is why almost everything you see in the universe is made out of carbon. Nitrogen is the 7th element on the periodic table and, believe it or not, by far the most common element in our atmosphere, making up over 70% of the stuff we breathe. It's got 5 electrons in its valence shell, which allows it to form super strong triple bonds like cyanide and N2, which is the stuff in our atmosphere. In fact, these bonds are so strong that plants can only get nitrogen in the form of ammonia, which has much weaker single hydrogen bonds, and the only way ammonia forms in nature is through lightning strikes vaporizing into in the atmosphere, which you can imagine isn't very common. Luckily, there is a kind of bacteria that somehow figured out how to do it with an enzyme, but this enzyme is so ridiculously complicated and not even really that efficient that we instead use the Haber-Bosch process to manufacture ammonia on an industrial scale. It's basically nuclear fusion, but with ammonia. This process alone is so terrible that it uses up over 1% of the entire world's energy. But without it, we wouldn't have food, so there's a Nobel Prize waiting for anyone that can discover a more efficient process. Oh, and it can also be used to cool superconductors. Oxygen is, the stuff that we breathe, and without it we would all die, so it's pretty important. Interesting enough, it's the 3rd most common element. I expected the pattern to continue after hydrogen and helium, with lithium being the 3rd most common, but instead it skips like 5 of them before jumping back to carbon and being quirky. It's easily the most common element in the Earth's crust at over 40%, and can I just say, my god, is this a beautiful infographic. Thank you, elements.visualcapitalist.com. I just wish it was 16 by 9. The reason oxygen is so common is because it really likes to form compounds. I mean, you give it an iron oxide. You give it a carbon, and bam, carbon monoxide. Don't breathe that. Nothing is safe from oxygen. Not even itself. Oxygen is more basic than a pumpkin spice latte because of its unique configuration, allowing it to join up with 2 hydrogens because of the 6 electrons in its valence shell that want to be 8 because neon is cooler. Liquid oxygen is also magnetic, which is pretty weird to think about and gives me existential dread. Fluorine is the 9th element on the periodic table and our first halogen. Unless you count hydrogen, but most people don't know where to put that, so I'm just going to give this one to fluorine. Halogens are the far right group on the periodic table and easily the most reactive because they're only 1 electron away from being in a stable configuration like the noble gases. Fluorine is so reactive that it's often used in glass etching, and it's the main ingredient in hydrofluoric acid, which is the stuff they used in Breaking Bad, which makes it really good for your teeth. This is because it replaces the hydroxyl ion or something. I don't know, I'm not a dentist, but it's very important. Fluorine is also used to make CFCs, which, if you don't remember, the stuff that almost burned a hole through our ozone layer and will still be recovering from it until 2066. And it's used in Teflon, which is very toxic and has led to a lot of accidental death and cancer. I can see why people are afraid of it. But no matter what the brainworm man says, it's very safe and does not, in fact.
Turn the friggin' frogs gay! Do you understand that? Turn the friggin' frogs gay! Shit crap gay! Frogs friggin'...
Neon is the 2nd noble gas, and it's primarily used for, well, Although, modern signs typically use LEDs to mimic the effect of neon, because it's very expensive and hard to work with, plus LED signs look much cleaner anyways. All noble gases actually emit light when an electric current is passed through them. However, neon emits a very bright, striking red glow when ionized, compared to, say, argon, which emits a gross, weird-looking purple. Other than neon signs in old-school plasma screens, neon basically has all the same uses as helium. You can cool it down for superconductors, or combine it with helium to make an extremely powerful, scientifically pulsating laser. And that's about it. You'd think neon would be more interesting, but nah, it's really just helium's older brother. Video's over. You can leave. Sodium is the 11th element and the leading cause of preventable death worldwide, killing more than every single infectious disease combined. Salt is actually pretty good for you and a rather important mineral for bodily function. However, Americans eat... My god, is that a lot? How are there not more deaths? This is insane. The reason it's such a problem is because in its consumable form, sodium chloride or table salt, it's very water soluble, meaning it attracts water into your bloodstream, increasing blood pressure, which can cause strokes and heart attacks and all that good stuff. But hey, it tastes pretty good. Magnesium has a lot of similar properties to our friend Beryllium. It's a lightweight, squishy, reactive, and toxic metal. This is because they both sit in the same group as alkaline earth metals, with 2 electrons occupying their valence shell, which gives them their unique properties. Unrelated tangent, but while I was researching magnesium, I came across this article that says magnesium makes up over 13% of Earth's total mass, and I thought, huh, that's cool. But then it claims that that's the same as Mars, and that makes absolutely no sense. But I looked it up, and yeah, Mars weighs 10 times less than Earth. I'm so used to thinking they're basically the same, but Mars is actually tiny compared to our planet. Anyways, where was I? Oh yeah, magnesium is super important for bodily functions because it's a key component in a lot of enzymes our cell uses to carry out reactions. The main one being this guy, hexokinase, which is the enzyme responsible for the phosphorylation of glucose during glycolysis. If you have no idea what any of those words mean, don't worry, because neither do I. All you need to know is it's important. Aluminum is the type of can I'm drinking out of while making this video. Believe it or not, but aluminum cans are actually lined with plastic, because if they weren't, your soda would taste all aluminum-y. You can't escape microplastics. Aluminum is the cheapest metal, not counting steel of course, or lead, but I don't know why you would need to buy lead unless you want to poison a child. Aluminum used to actually be more expensive than gold, just like 2 centuries ago, because it was extremely difficult to refine since it required high heat. It was actually so valuable that during the construction of the Washington Monument, they put a 100-ounce aluminum cap on it that cost $225, or around $7,000 adjusted. That same amount of aluminum would cost like $7 now. They definitely did not get their money's worth. Of course, nowadays aluminum is so cheap to produce that we use it for disposable diabetes cans or
the aluminum foil. Never settle for less.
Silicon is the 14th element on the periodic table, and if you notice, it's got the same Goldilocks number of electrons that carbon has. For this reason, some speculate that silicon-based life would be possible, since it can form the same complex structures that carbon can. It also helps that silicon is significantly more abundant on our planet than carbon, and there's no reason to think it would be different on others. While carbon-based life breathes in carbon dioxide, taking the carbon in for growth and releasing the oxygen, you'd expect silicon-based life to do the same thing, breathing silicon dioxide. Silicon dioxide is sand, so be thankful that you're carbon-based. Silicon, like boron, is a metalloid, meaning it exhibits properties of both metals and non-metals. Silicon is also a semiconductor, meaning it's somewhere between a conductor and a resistor, making it super useful for transistors, which is why it's used in computers. While there are other semiconductors, silicon is dirt cheap, and who doesn't love a dirt cheap transistor? Phosphorus is the second most common mineral in your body after calcium. Serving as the backbone of DNA, it also strengthens your bones and teeth, keeps your membranes in your cells, helps your nervous system function, delivers oxygen through your body, a whole bunch of other things. It would probably take me like an hour to list, but yeah, it's pretty important. White phosphorus is incredibly reactive and used in warfare, especially in one specific Middle Eastern war going on right now that I will not name in fear of being striked. Unlike its brother, red phosphorus is actually pretty chill. Just don't mix it with water. Phosphorus comes in all different kinds of flavors, so make sure you try them all. Just don't make phosphoric acid. I hear it's bad for your skin. Phosphorus also glows in the dark. Ooh! Phosphorus was discovered in 1669 when Henning Brandt cooked some urine in a pot. Don't ask me why. Sulfur is the 16th element and is abbreviated as S, not Si, as I learned the hard way. You've probably heard that sulfur smells really bad, but it's actually pretty chill by itself. However, it's fairly reactive, and if given the chance, it will form hydrogen sulfide, the chemical that gives it its nasty, characteristically rotten egg smell. Sulfur is also a common characteristic of... hell. But it's not all bad. There are some cool things about it too. When you light it on fire, it glows blue. On second thought, that might make it even scarier. Moving on. Sulfuric acid is the stuff in car batteries and your stomach. Can we be done with this element? I don't like this one. It's horrible in every way. It seems like there's nothing good about it. Chlorine is probably one of the scariest elements, and you guessed it, it's the second halogen, after fluorine. And just like fluorine, it has a ton of mundane and inconspicuous uses, like how we dump a ton of it into swimming pools. But it's actually pretty chill, because it kills all the bacteria and viruses and gross stuff living in there. It's also one of the main ingredients used to make mustard gas, used in chemical warfare that killed tens of thousands of people and led to long-term health complications like respiratory issues and cancer. And it's one of the main ingredients in table salt. It's also what makes up CFCs, which are the stuff we used to put in literally everything, and burnt a massive hole in our ozone layer, which I blamed on fluorine, but it's really more of a team effort. It's got one of the least creative names. Chlorine as a liquid is yellow-green, so guess what they named it? Yellow-green. I could honestly make an entire video on dumb chemical names. Argon is pretty cool. The only thing I know about argon is that it's the element that I always forget is the third most common in our atmosphere. It's even above CO2, weirdly enough, by a factor of almost 30. Interestingly, the reason it's so common is due to potassium-argon decay, which happens so often that we use it all the time to date rocks, and the leftover argon products just kinda stick around in the atmosphere. Argon is a noble gas, which means it kinda just wants to be left alone and doesn't react with anything. Due to its abundance on Earth, this makes it extremely useful for all sorts of applications like welding, light bulbs, document and artifact preservation. Basically, if you want anything to not react with anything, argon is your guy. It also makes a purpley bluish glow when you pass an electric current through it, and it's the stuff inside those weird looking plasma ball thingies. Are you gone yet? Alright, I'll stop.
Ba 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 na na. Ba 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 na 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 na.
Okay, well, that's enough of that. If you didn't know, potassium is a very common mineral in bananas. However, you'd still need to eat like 11 a day to get your daily recommended intake. If you watched my video on argon, which you should, you'd also know that potassium loves to decay into this stuff, which is why there's so much argon in the atmosphere. This means that bananas are radioactive. They're not that reactive. You need to eat like 10 million of them in one sitting to die of radiation poisoning, which I think you'd die of other things first. But they're reactive enough that real scientists with real PhDs working in real labs, often using your real tax dollars, use the unit BED or banana equivalent dose when talking about radiation. You can't make this stuff up. It also makes a purpley flame when lit on fire, and other than that, it's basically just sodium on steroids. It's a light, squishy metal that's super reactive, an important electrolyte, blah blah blah.
I see you got the extra whipped cream in there, huh?
Yeah.
Yummers.
More like calciummers. But seriously, kids, calcium is a very important mineral for bodily function, and calcium deficiency can lead to muscle cramps, bone loss, and even chronic medical conditions like osteoporosis. But what makes calcium so important? Well, if you've taken anatomy, you'll know that not only is it the stuff that solidifies and strengthens your bones, it's also the main electrolyte driving the muscle contractions in the sarcolemma. But don't have too much of it, because it causes kidney stones, which you don't want. Unless you're a masochist. Fun fact, it's the stuff that makes up limestone, which is the same stuff that makes up chalk, which is the same stuff that makes up Tums, like the antacid. The more you know. I personally hate drinking milk. If you don't like milk, cheese has a lot of calcium too. If you don't like cheese, there's seriously something wrong with you. Go see a doctor. Scandium. Scandium is the 21st element, and while found in the D block, it's often classified with yttrium and lanthanides as a rare earth metal. The category is a bit of a misnomer because, while they aren't actually rare, they have been historically difficult to isolate and are often found together in ore. It gets its name from its origin in Scandinavia, where it's still primarily extracted. However, most commercial scandium is produced as a byproduct of uranium refinement. It's often used as an alloying agent that strengthens aluminum for aerospace applications. It's also a key component in mercury vapor lamps, which are used in large buildings and factories due to their high brightness and efficiency. It has a lot of interesting potential applications, but its high price of $500,000 per kilogram means it's reserved for very specialized applications. Seems like titanium is all the rage with tech conglomerates recently. They're pretty good in everything from smartphones to smartwatches and even your knee joints. I mean, what is happening? Or at least it was all the rage until they realized they could market AI as a feature like they couldn't already do that with their old phones. No, you gotta get the 16 to run the software.
I am genius.
I mean, don't get me wrong, titanium is really cool. It's as strong as stainless steel while being half the weight, but it's not a reason to spend $1,000 on a phone. I mean, they only put like 18 grams in there anyways. Most titanium is actually used to make titanium dioxide, which is a food additive that's banned in Europe and linked to cancer and inflammation, so that's fun. Vanadium is named after Vanadis, a Scandinavian goddess known for her beauty and love. Ooh. It also has about the half-life of how long it takes me to make a video. Vanadium was discovered in 1801 by a Mexican professor, however his credit was stolen by a Swedish chemist named Niels Säfström in 1830. Typical Swedish. Vanadium is also acid-proof. Unlike the Swedish. Vanadium is primarily mined in Brazil, South Africa, and China, and also Utah, I guess. Only the coolest of places. According to the International Agency for Research on Cancer, vanadium is a possible carcinogen to humans, which means absolutely nothing. My editor, which is me, has just informed me that all of the information I've used from this video has come from a sketchy vanadium foil selling website. So in the interest of not disinforming the public any further, I will be ending the video. Chromium is a free and open source web browser project primarily developed and maintained by Google. It is a widely used code base providing the— wait, hold up. My bad. Nope, wrong article. Chromium is the 24th element on the periodic table and an ingredient in the Celsius I drank this morning, which actually was not half bad. It turns out chromium is important for blood sugar control. However, it can also cause liver damage, so be careful. Chromium is most known for being pretty, because it's found in a lot of colors and pigments and dyes. I mean, it's literally named after chroma, meaning color. It's also an important component in steel, making it resistant to corrosion, and it's the only known element that exhibits anti-ferromagnetic properties below room temperature, meaning it doesn't react at all with any magnetic fields, which is super important for like data storage and stuff.
I don't wanna be found. I don't.
What we do here is go back.
Manganese is the 25th element, and popular to contrary whatever, it's actually not named after magnesium. It's named after Magnus, which means magnet in Latin, because manganese dioxide contains some magnetic properties. However, manganese itself is not magnetic. It's also the 12th most abundant element in Earth's crust, and has been used in steel since the Spartans for their swords, due to its impact on strength. It's also used to remove green from glass windows or something, I don't know. You can also get a ton of like neurological diseases from inhaling it or whatever. I don't know, it's kind of a shockingly boring element. I thought this one would be more interesting. I mean, I made this whole fancy animation and wallpaper and background and stuff. I was gonna talk about all the cool uses. Iron is the 26th element and the best material to make beacons with. I will die on this hill. It's also the second most abundant metal on Earth after silicon, and it composes about 80% of the inner and outer cores. It's also the main component of meteorites, and the reason it's so common is because it's the stable end product of nuclear fusion in stars. This element's so cool. The reasons for this are very complicated. I'm not getting into that. But a lot of scientists predict that before black holes, the universe will just be iron. It'll just be iron for a very long time, and then it will become black holes. So it's like the second to last step. It's also the main ingredient in steel, which is pretty common. It gives Mars its red. It's responsible for rusting. Crucial for hemoglobin, which is a protein in red blood cells. I could probably make a longer video about iron than carbon but we don't have time for that. So cobalt.
I don't know what the that was.
Cobalt is the 27th element and is pretty shiny, sparkly, pretty shiny blue. Pretty blue. It also kind of looks like meth. Cobalt comes from the German word Cobalt, which means an evil goblin. Okay. Now, the reason it's named after such malicious goblins is that when smelted, it gives off poisonous arsenic trioxide gases that were thought to have replaced the silver metal the goblins had stolen, which we all know was proven extensively to be scientific truth by Arthur Cobalt in 1996.
Yeah, funny little green ghouls.
What? Like in movies and cartoons? What?
Little green ghouls, buddy.
Don't write ghouls.
I'm not.
The term nickel is commonly a misspelling of nickel. Nickel can refer to the wait, hold up. Nickel is the 28th element, and while you probably associate it with the coin nickel is only actually 25% made of the element nickel. It's the other 75% being copper. Nickel is one of only 3 elements that are ferromagnetic at room temperature, and as expected, it is an ingredient in steel. It's also apparently one of the most common skin allergens. It's named after the German word Kupfernickel, which means devil's copper, because miners initially found it difficult to extract from the ore. Funny how almost every metal is named after some demonic creature because it was hard to mine. Copper is the 29th element and is used in a whole lot of things. In fact, I wouldn't even be able to have this hobby of making crappy little internet videos without it, because wires and transistors and all that computery gizmo-wismos are made of copper. Copper was invented in 11,000 BC by Sir John Copper, a British policeman known for his expertise in tool and pendant making. He'd earned a name for himself by defeating the rival tribe that lived across the river. I don't know where I'm going with this story. Copper is also super antimicrobial because it releases little copper poisons to kill the cells that are on it. It's also what was used to build the
There was something in the air that night. The stars.
Washers and nuts and bolts and screws and whatever little pieces of metal we can think of that is galvanized. It has to be galvanized or solid.
Zinc is the 30th element, which is written as XXX in Roman numerals. So you know what that means. Now you might have heard of something called galvanizing. It involves a lot of complicated steps, including various causticisms, picklings, rinsings, dryings, more pickling. But all of this is for a very important cause, which is to coat the metal that you're galvanizing with zinc, which acts as a protective barrier against rusting and oxidation and erosion and all kinds of stuff like that. Why zinc? Well, zinc reacts more quickly with oxygen than iron or steel, so even if the zinc coating gets scratched, it still protects the metal underneath.
Number 2. only speak in glory. Yeah. Leave your baggage at home.
None of that deep shit.
Number 3, don't tap the glass.
Gallium is probably one of my favorite elements. It's a post-transition metal, or basic metal, and sits in the middle right of the periodic table, which means it has properties of both metal and nonmetals, which is why it's a weird little liquidy dude. Gallium's got a melting point of 85 degrees Fahrenheit, which is just barely above room temperature, which is why it melts after just like a minute of holding it in your hand. The reason it has such a low melting point is because in a solid, it tends to form dimers, which are just pairs of covalently bonded gallium atoms, which is a much weaker bond than most other elements. When you heat up a metal and put it next to another metal, it kind of conjoins with it and creates what we call an alloy. But because gallium's melting point is so low, it can do this at room temperature, which is why it alloys with aluminum. But since the bond is so weak, it just snaps off really quick. Or a weak piece of gallium. Germanium is the 32nd element on the periodic table and exhibits a lot of similar properties to silicon, which is why it's used in transistors and semiconductors. It was discovered by Clemens Winkler, a German chemist, in 1886, but it was predicted by Mendeleev 15 years earlier. While some could make the argument that Clemens stole Mendeleev's credit, in all fairness, the Germans have done much worse to Russia throughout history, so I'm gonna let this one slide. While not toxic in teeny tiny amounts, supplements of germanium can cause kidney failure. However, some idiots still buy it and eat it for health purposes, and it's caused 30 deaths. Dude, my throat hurts so bad now. I think I'm losing my mind. I don't know why I put so much effort into that Hitler impression.
Don't you see, D? We've already won. Hey, what? Whoa, what's going on with me? Oh, William, what's going on is that you just drank a cup of poison.
Arsenic is one of the oldest known poisons, being used by Emperor Nero to assassinate his stepbrother all the way back in 55 AD. Arsenic also sublimates like CO2, which means, except for under extreme conditions, you will never see liquid arsenic because it just goes straight from solid to gas. It also adds a blue color to pyrotechnic displays and is used as a semiconductor. I don't know. I'm not feeling too well. I think I might sound low.
Let Trumpomania run wild, brother! Let Trumpomania roll again!
Yes, that is Hulk Hogan's signature look. Blonde Chinese hair and the skin of a hot dog. It's awesome. The whole thing's fake, but it's really awesome.
Selenium is the 33rd element, and I swear on Hulk Hogan's grave, I did not plan this, but it's a vital nutrient in testosterone production. Yeah. Whoa, selenium's way more interesting than I thought, though. It's named after the Greek word for moon, Selene, and it is photovoltaic, meaning it can turn light into energy. And they actually use it all the time in solar panels. It's also used to make glass less green. What the hell is up with that?
Esto es bromo.
Bromine is the 35th element and the only non-metal that is liquid at room temperature. It smells nasty and is named after the Greek word bromos, meaning stench. Bromine is incredibly harmful to the environment. Remember when we talked about chlorine and all the damage that caused to the ozone? That was a whole thing. Well, bromine is 40 to 100 times more destructive to the ozone layer than chlorine. And up to half of the loss of the ozone above Antarctica is due to methyl bromide, which is used as a fumigant. But hey, it's not all bad. It's used in water treatment because it's a powerful disinfectant, and it's a catalyst in a lot of pharmaceutical manufacturing.
Ahora, para quitarlo del tubo, solo tengo que calentarlo un poco poniéndolo en agua. Esperaba que al estar congelado no tuviese una reacción tan violenta, pero aún emite.
There's a starman waiting in the sky. He'd like to come and meet us, but he thinks he'd blow our minds.
This legitimately might be one of the stupidest intros I have ever made. I think I am beginning to lose my mind. Krypton is the 36th element and is named after the Greek word kryptos, which means hidden or secret. It actually has the same name origin as, like, cryptography. So no, Superman's home planet is not named after the noble gas. Oh yeah, Krypton is a noble gas. Did I mention Krypton was a noble gas? Well, it is a noble gas. But despite being a noble gas, it can actually form compounds with fluorine. Now, they decay at room temperature, but it's so reactive that it reacts with gold, which, if you don't know, gold is like one of the least reactive substances. It can also oxidize xenon, which is another noble gas. Man, I can't believe we're already done with the 4th period of the periodic table. This is a saga that has taken me, Jesus Christ, 8 months? Rubidium is the 37th element and is used in atomic clocks because it is one of the most stable elements. Rubidium is named after the Latin word rubidus, meaning deepest red or dark red. Not because it's actually red, it emits bright red spectral lines when it's excited, which was how it was discovered in 1861. It has a crazy low melting point at only 102.7 degrees Fahrenheit. That's like a mild fever. It's one of the most reactive metals.
That was rubidium.
Because of its location at the bottom of the alkali metals. And in fact, the only 2 metals that are more reactive than rubidium are cesium and francium, which I will get to probably in like 7 months. Rubidium is also like decently abundant, making up 0.01% of Earth's crust. It's not crazy expensive either. Like, if I got more than 15 views per video, I'd probably... Strontium is the 38th element and is very similar to calcium, which is why you can find some in your bones. It's named after the Scottish village of Strontium, where the mineral strontianite, which is strontium carbonate, was first discovered. It's super reactive because, like, duh, of course it is. And it's a byproduct of... Strontium chloride is also used in some toothpastes designed to help with sensitive teeth. When it's finely shredded, it can also ignite spontaneously in the air, so to prevent that, they store it under kerosene. Now, that seems like a terrible idea waiting to happen, but hey, I'm not the scientist here. Also, engagement farming. Here's a comment, leave a comment, get a comment in the video. It's a thing now, bye. Yttrium? Yttrium? How the fuck?
Yttrium
is the 39th element and is named after a Swedish village. I swear to God, if those Swedish don't chill out. Yttrium is a rare earth metal, which does not mean it's rare. Apparently. It just means that if you find a rare earth metal, it's probably mixed together with another rare earth metal, and good luck separating them. Yttrium was also found in moon rocks brought back by the Apollo missions, which supports the theory that the moon was formed from the Earth's debris. It's also responsible for the red color in those old CRT TV thingamabobs. It's also found in cucumber and beetroot. It's toxic, so do not eat cucumber or beetroot. Zirconium is the 40th element on the periodic table, but it's the last alphabetically. At least that is until my petition to rename the 119th element to Zirconium gets enough signatures. It's incredibly resistant to acid and corrosion, which makes it super useful for chemical manufacturing plants and nuclear power plants, and actually about 90% of the zirconium produced annually in the world is used in nuclear power plants. The average human body contains about 250 milligrams of zirconium. That's like 40 cents. It's also used in like cheap wedding rings or whatever. Niobium is named after the daughter of Tantalus, which is what tantalum is named after because niobium used to be indistinguishable from tantalum until they realized it wasn't, and so they changed the name. It's a whole complicated thing. At extremely low temperatures, niobium becomes a... It can also be anodized to make it look
Pretty.
It's also used in the petrochemical industry to produce gasoline and oils and natural gas and and a bunch of other
Wonderful.
terrible things. The U.S. Department of the Interior designated niobium as a critical mineral in 2018, and yet we still import 100% of it from Brazil and Canada. Roughly 80% of the world's produced niobium is used to manufacture high-strength steels, because of course it is. Why is everything in steel? Molybdenum is the 42nd element, and unlike the past 20 elements, it's actually non-toxic and is important in a lot of bodily functions. It primarily helps break down toxins and sulfites found in your body, but it also helps transport blood oxygen. It's named after the Greek word molybdos, which means lead, because it was historically confused with lead ore. Actually, a lot of the elements further on the periodic table are just named after ores that looked similar to it, because we didn't quite have the technology to distinguish them when they were discovered. It's also got one of the highest melting points of any metal, just behind tungsten, rhenium, and tantalum, at almost 3,000 degrees Celsius. It's also an ingredient in steel because, of course it is. Technetium is the 43rd element, and is the first element that can be artificially produced and is not found on Earth. However, its spectral lines have been observed in some kinds of stars, which means it can be naturally produced. It exhibits superconductivity at low temperatures, and it dissolves in nitric acid and sulfuric acid, but not hydrochloric acid. It's also used in medical imaging because of its radioactivity, and in fact, it's one of the only elements that has no stable isotopes, which is a good reminder that no matter what you do, and no matter how hard you try,
nothing can last forever.
I am reincarnated. I was stargazing. Life goes on. I need all my babies.
Ruthenium is the 44th element, and surprise, surprise, it's toxic. It can also, stain your skin red. It's named after Ruthenia, which is the Latin word for
Russia.
Ruthenium was discovered in 1844 by Karl Karlovich Klaus. Do with that information what you will. The element is primarily used as a catalyst in several different applications. It's also used in the process that makes computer chips and silicon wafers. Fun fact, ruthenium is the primary ingredient in what is known as the Kreutz Taube ion, which is a metal complex that has two pentaminerithium units linked in a bridging puras, which of course completes the octahedral coordinate sphere of each metal. Rhodium, the 45th element, is pretty similar to ruthenium. It's named after the Greek word for rose because of the color of its salts. It's useful in a lot of similar things to ruthenium, but it's primarily used for catalytic converters, which are the things that are always getting stolen in your car. Catalytic converters are a very crucial component of your car. They convert all of the toxic carbon monoxide gas that's released during incomplete combustion into CO2 and water, so that your car isn't just constantly spitting out carbon monoxide and killing everyone. Another important thing that catalytic converters do is remove nitrogen oxides from exhaust gases. Our atmosphere is almost entirely nitrogen, so it's kind of inevitable that it'll get mixed up in the combustion, forming nitrogen oxides, which can cause acid rain. That's where rhodium comes in. It catalyzes the reduction reaction of NO2 back into harmless nitrogen and oxygen gases. And it does this more efficiently than any other metal. Why do I keep getting sick? I was sick 5 weeks ago. What's wrong?
That's palladium, 0.15 grams. need at least 1.6, so why don't you go break down the other 11?
Despite what Tony Stark says, palladium cannot be used to create an arc reactor. The metal really has nothing to do with nuclear fusion, and it's not toxic in its solid form, so I don't really know why the writers chose this metal. I feel like Technetium or Rhodium or Platinum would have been much better choices, but hey, I didn't write Iron Man. I don't even think they ever consulted me when I was a baby. Palladium is a pretty dense and expensive metal, and it's also used in a lot of catalysis, like Rhodium was, but again, I feel like Rhodium would have been a much better choice. Maybe it just didn't sound as cool, I don't know. Please forgive me, I've been playing a lot of Marvel Rivals lately, so I'm a little obsessed with Iron Man at the moment. But to be fair, there's almost nothing else that's interesting about palladium. It's basically just Rhodium 2.0. Oh, and it's also used in like dentistry fillings, I guess. Silver,
It's no use!
is like probably the only element that we've done in this row so far that you've actually heard of. And this is because it's a lot more common than other metals, or at least tends to be found mixed in with alloys of other commonly mined minerals. In the past, it's mostly been used for showing off because it's... But it also has antimicrobial properties, which is why it's still used in a lot of utensils and kitchenware. Really expensive utensils and kitchenware. Now, before like 100 years ago, bacteria was everywhere and you would very likely die from it, so any kind of help whatsoever is extremely useful. And this is why silver was thought to be pure and holy, and why it's famous for killing vampires and werewolves. But nowadays it's used in all kinds of different stuff, because apparently it is the most conductive metal.
Fish dinners, I just love free food, and you look like seafood.
Cadmium is the 48th element and is famous for forming very bright pigments, including cadmium red, cadmium orange, or cadmium yellow. However, you should probably not paint with it because it is toxic, like my ex. Cadmium is unique in that it's able to absorb protons very easily, which made it useful for nuclear fuel rods because they could absorb the nuclear radiation. However, it's not used as much anymore because it's toxic. Cadmium was also used in batteries. However, it's not used as much anymore because it's toxic. It's also used in infrared detectors and solar panels and corrosion-resistant metal coatings and low-melting alloys and even quantum image dots. Oh, right, they don't use it for any of those things anymore because it's toxic. Why is it so toxic? Well, the world may never know. No, it's because it sits right under zinc in the periodic table and it imitates zinc in your body, which is super important for all kinds of metabolic functions. Indium is the 49th element and can form Indian tin oxide, which has the unique property that it's both electrically conductive and transparent, so it can be used on like screens and monitors and stuff. It also can like bond to glass. Okay then. It's also one of the softest metals, and it cries when you cut it. What is this element, dude? Indium ions are also used in atomic clocks. I couldn't tell you why, but science-y reasons. Okay, bye. Tin is the 50th element and is one of the strangest but most important elements throughout human history. Tin by itself is a pretty weak metal, however when you combine it with copper it turns into bronze, which is one of the strongest alloys that early humans had access to. Tin kinda does whatever the hell it wants. Sometimes it just like randomly turns into powder, like crumbles into dust, because why not, or like it'll grow friggin' whiskers that short circuit electronics, like, I don't know, it's a weird little animal. Tin has a lot of similar properties to aluminum, which is why we used to use tin foil. However, once we figured out how to process aluminum, we switched to that because tin is expensive and it tastes really weird. Apparently tin also makes that weird squeaky crying sound that indium does, and the clip that I used in that video actually was tin.